Hello everyone, my name is Egemen and I am a third year university student in informatics, computer science, and I made a pathfinding algorithm and I would like to share this program with you guys. So let me start the program real quick and show you how it is and how it's made of. So first click, there will be the orange starting point and the cyan will be the ending point, and the program lets us draw a maze, and we can draw the maze like anything we want. And for example, I want to make like one road that is like that has a lot of this type of stuff, and I also want to make like one road that has a faster way to reach, and I want to like close this real quick like this, like this, and like this, and here, and I want to like trick the program time to time and like connect these mazes and go like this, and I want to make like a dead point here. And okay, so when we start the program, what should happen is that, let me do this also. What should happen is that the program should choose the fastest way to reach to cyan, and sorry, I wanted to like do this like this. So the fastest way will be obviously like from here to here, and but like if the algorithm is like not correct, it could have like went from, I don't know, like from here and took this road instead of this road. But because the algorithm works properly, it shall start. And okay, so apparently this way is faster than this way. So my program beat me. Yeah, that's the fun part about informatics and programs. So as you see, like it just calculates and finds a faster way, and apparently this way was faster than this way, and I have no idea how. But let me start it again. Yeah, just to make sure, and it still goes from that way. So yeah, and how it works is quite simple, and I would like to explain this to you. So our project is like split into three files: algorithm.py, main.py, and spot.py. And in spot.py we define the spot class, which represents each cell or node in our grid, and every cell has several responsibilities. So here are the spot's attributes. So basically row and col are the hold to like grid conditions, grid coordinates, and x and y values are like the pixel positions. That's why we are like times col times width. That's why we are doing it like that, so that like it holds the pixel positions. It's calculated by like multiplying the grid coordinates. And self.color is white, and the color represents the cell state. And because like the default color is white, it is like whether it's like unvisited, like part of the part, a barrier like the start or end, but it will always be white at the beginning. And self.neighbors is a list that will hold adjacent spots, adjacent cells to be exact. And here are some state methods, and these methods like check or update the cell state. For example, isBarrier tells us if a cell is barrier tells us like if a cell is an obstacle, and method like make start, where is make start, make start or make end or like make path, they change the cell's color to reflect its role in the algorithm. And drawing to neighbors is I use this function right here. So I'm using Pygame, by the way. It uses Pygame to render the cells on the screen, and the update neighbors method basically looks at the adjacent cells, and it's if there are not barriers, they add them to the list, and yeah, that's pretty much how it works. And there is like a comparison method, and it is this one, and it is just a placeholder that lets Python compare cells like when we use priority queue in our algorithm. And this is basically how it is. And the algorithm is the most complicated one. This file contains a star finding, like pathfinding logic. I use a heuristic search or like a function. This function calculates the Manhattan distance between 2 points. This helps the algorithm estimate how close a cell is to the target, guiding the search efficiency. And path reconstruction, here is the function for path reconstruction, and the reconstruction path function like traces back from the target node to the start node using a dictionary called like came from, as it traces came from as it traces the route, and it marks each cell as part of the final path. And here is the A star algorithm, and this is the main function basically. This is where the magic happens, and it uses priority queue. I imported it from queue, it uses priority queue to manage which cell to visit next based on the F score, a combination of the cost so far and the heuristic, sorry, I always say heuristic instead of heuristic, but it is heuristic, not heuristic. I'm really sorry for that. And G score basically keeps track of the cost from the start to each cell, and F score basically estimates the total cost from the start to the end through that cell. And as the algorithm processes each cell, it updates these scores and marks cells as open or closed. And here are while open sets, and I don't know, I'm not sure how to explain it. Honestly, this is my first YouTube video, so I'm kind of anxious, but here is the function for it. I will try to explain more and more, but basically once the end is reached, the path is reconstructed and highlighted, and this modular approach not only keeps the logic clear, but also makes it easier to swap or swap out or tweak parts of the algorithm later on. And finally we can go to main.py, and I import the files here, and I set up the Pygame. in this area. And oh, I don't want to break anything. Let me fix that real quick. And so basically this is like the function to make grids, and this is the function that draws the grids, and here is like the main function. And while the program is running, also you can change the rows from here if you would like to. While the program is running, it it draws with these values that we set, and the functions like make grids and like the make grid, where is it, draw grid, make grid, yeah, it uses these. And basically, yeah, the core of our visualizer is basically interactivity. So these are like the Pygame functions to like see if the mouse is pressed, or like see, how do I say, like for example, if like the mouse got pressed for the second time, it is like the ending, how do I say, it is like the sign dot. And for the event type, no, sorry, I don't mean this. And this is how you draw the black cells basically. And yeah, and that's honestly basically all. I'm sorry, like, and also, oh, I forgot the CK. CK basically clears the grid, and spacebar basically starts the game. And yeah, that's, I think, pretty much all, as you can see in the demo. And the visualization updates in real time as the algorithm searches for the optimal path, and this interactive feedback is a fantastic way to understand how pathfinding works under the hood. I'm pretty bad with explanations, but I'm trying to improve, and this is why I make this video. I even like prepared a little how do I say, script for this video, if I gotta be honest, but I try to look through it time to time. And yeah, anyways, to summarize, the spot class is basically for representing each grid cell, and the A star algorithm that computes the path, and the main.py just handles UI and user interaction like pygame.kdown and stuff. And yeah, thank you so much for watching. If you found this explanation helpful, please give it a thumbs up, I guess, and subscribe for more coding tutorials. Even though I will probably like, I just did this so that like I can explain this on GitHub, and like I have, you know, more experience talking and explaining, which is a area that I lack of. Because imagine if I'm in an interview and like the person asks me a coding question, and like, oh, if I can't explain it, I would be in trouble. So that's why I made this video, and I don't think I did very well, but I hope this video was quite helpful. Thank you for watching. I hope to see you in another tutorial, maybe. We'll see. Bye.